Hi, Jiffin. Hi, Jiffin. Thanks for joining us today.
Hi, Sid. Yeah, it's been
Hey.
a while. So
So, what time is it there, Jiffin?
it's 10:30 at night. Yeah, 10:30 p.m. Like
Okay.
8 feet. Yeah.
Well,
At the
thanks for
moment,
joining so late.
yeah,
Um,
fine.
so, okay, so let's get started with the questions that you had because it's late for you. And if you wanted to leave early, I want to make sure we've covered all the topics that you had in mind. Um, so, let's go over that. Um,
Ah, it's okay. Like I will be staying till end of this meeting for sure.
okay. Okay,
Like
good to
if you
hear.
have important topics, like we can discuss that and we can go through that. Uh, we can take it at the end as well. That's fine. Absolutely
Sounds good.
fine.
Okay, sounds good. Okay, all right. So here are the two topics that I want to go over today. I don't know if Guy is here today, but let me ask Vianney. Did we decide on what the Azure API should look like?
Not yet.
Okay, can we finish that today?
Yeah, sure.
Okay, and then once we're
Do,
done with that, sorry, go
is
ahead.
guy around?
I
No.
don't see him in the meeting.
Yeah. Yeah.
Okay, so this is where we left off. So what we said was we're going to have bucket access. So this is the downward API. The downward API is going to look like this, where we're going to have something called bucket access info, and the bucket access info is going to go down all the way into the pod. It's going to have three different um, fields: one for S3, one for Azure, and one for GCS. And we defined the S3 field so far, and we said S3 field is going to have credentials, endpoint, bucket name, and region. And then we got into the conversation about Azure, where it was pretty clear that we need endpoint. And then we were trying to understand what else we need. It seemed like there are multiple ways to authenticate, right?
Sorry.
Danny?
Yeah.
So is the storage account name the same as access key, or is it a combination of?
Yeah.
Tell me. Can you
Yes.
elaborate?
There is some kind of echo.
Oh,
Um,
1 second.
so the storage account name is the bucket name, right? And you need a container name which is basically a folder to effectively write something. And what Guy said last time is if you don't provide one, there is one which is provided by default. I'm not sure about that, but the thing is that the container is not a bucket, it's just a prefix or a folder if you want in the S3 terminology. Um, for instance, if
What are
you
you
write, yeah,
sharing? I see something blocked the screen. Oh, okay, now it's better.
I was just changing the microphone. It must sound better.
so for instance, just to quickly sum up, so if you write in two different containers, you're bound by the performance of the storage account. You have a finite amount of you have limits basically per storage account and not per container, because a container does not exist. It's just a prefix or folder. So definitely the bucket name is storage account name, and you can consider the storage account name as an access key somehow, right?
I see. Okay.
And the secret key, or so the problem is in Amazon, it's very clear, and everybody has a secret key, and you can assign different policies to different secret keys. But in Azure, in the Azure world, it's not as simple. You only have you only have two secret keys, which are basically the root keys. It's a little bit equivalent to the Amazon S3 root keys. and it's basically an anti-pattern to use them directly. Like in Amazon, it's not advised to use the rootkey when you do something.
Got it.
So the only way to simulate users or service users in Azure is to generate SAS tokens. So we double check with Guy the other day.
Mm-hmm.
And basically, so SAS tokens are temporary keys by definition.
Mm-hmm.
The thing is you can put, so you have to put an expiry time,
Mm-hmm.
an expiration time.
Mm-hmm.
And you can put something which is super far away, like 5 years if you want. And this
Oh,
way you
right.
can
I
simulate
remember
a long-lasting key if you want.
this. Oh, but
So
okay.
by opposition to STS tokens in the Amazon S3 world,
Mm-hmm.
where Amazon STS tokens are, I think it's only 36 hours or 72 hours max for a temporary key. A SAS token in practice has no limit in duration. So we can assume they are permanent keys, right? It's a bit far-fetched, but so if we do so, we should not store the secret key, but we
Okay,
should.
so
Yeah.
mm-hmm. So let me ask you this. So is there a access mechanism where there's no, so you're talking about a certain kind of access mechanism where we have this concept of expiring secret key, right, or expiring credential, right? Isn't
Yes.
there some concept where we have long-lasting keys or forever keys?
No, there is no such thing except the two secret keys you have when you
The
create a
root?
storage account.
Okay, I see. And is the storage account the same as a bucket? Is that what we said?
Yeah,
Or
it's
okay,
the concepts are a bit different, but
can we
it's a
have
bucket. Yes.
multiple? Can we have multiple root access key secret root credentials for the same storage account?
No, only two, and
Only two. Okay, I
you
see.
can rotate them, but basically it's an admin operation.
So you're saying there is just no way to have access key secret keys that last forever. You have to have something that lasts a long time.
Yeah.
Can we have something that is say active for 10 years or something, or is there a limit on how?
No, there is no limit. You can put 10 years, no problem.
Okay, yeah, we should probably like set a default like that and move forward, at least for now.
Yeah. So I don't think it's I mean, something we could do as well is to basically in the case of we could give the secret key, the unique secret key. There are two of them, but we could give the second secret key if you want. We could return that as credentials for Azure, as a special case. But the thing is, everybody would have the same key, but it would work for some application, definitely.
I don't think that's a good idea. Just in terms of designing a system where like why even have multiple why even have this cozy wiring if you're just going to share the same credentials?
Yeah,
like
no.
Yeah,
No, but sometimes you just want an app to run and it's fine to share the key and there is no security issue because you give access to the bucket anyway. So
right, but cozy is about minting buckets and credentials programmatically, right? It's for the case when you haven't already done it yourself.
no, but since we are also creating the bucket dynamically, so basically we are creating a storage account, right? So when we create a storage account, we are returned two keys. That's the default, if you want. And when we ask Cozy to meet credential, we return the second key. And everybody will have the same key.
Right, but the issue there is, my expectation as a Cozy user is going to be that if I create a BAR and I bind a pod to it, and then later I delete that BAR, the secrets that were given to that pod should no longer work, right? Otherwise, because
Yeah.
the guy who consumed that BAR with his pod could have taken the secrets and exfiltrated them and stashed them somewhere, right? And so now he
Right.
has access to the bucket independent of Kubernetes. So when I delete that BAR, my expectation is anything that was using it can no longer access the bucket because I've deleted the access request. Access should have been revoked. But in this with this proposal, if everyone's just sharing the key, deleting the BAR does nothing because the key still works, and anyone who
You can rotate the keys if you
Hmm?
want. You can rotate the keys, so you can basically.
yeah, but I mean not within the life cycle of one pod, right?
Yeah, so basically you rotate the key for everybody accessing the bucket.
But all of the old pods with all the old BARs should continue to be able to use the old key. And if I delete a particular BAR and all the pods associated with it, it should go away. And then anyone using that particular key should not have access there. I don't know that. I mean, we could argue for a long time about the exact semantics, but my understanding is that the whole point of having these BAR objects is that like it's for minting a new credential for
Key
use
chunk.
by somebody, and then the deletion is supposed to revoke something, and that precludes any scheme where you share, because then there's no revocation ever.
So then we have to use SAS tokens.
Yeah.
But for
But
revocation, it's another problem. So I'm checking if we can revoke SAS token. Sure.
Yeah, can you look that up and get back to us? And let us also know if this set of fields that we have, the 4 fields, is that enough, or do we need more? Is there any other information needed for
No,
Azure?
that should be enough. So and the fourth parameter would be either the secret key if we choose to use secret keys, or the SAS token, but it's basically a string. So
Understood. Okay, that sounds good then. All right, so let's move on from okay, so can we call that as an enough of a like do we feel like this is we have enough information about Azure to now move forward and look at GCS, or is there something else we should discuss about Azure? Vianney?
yeah, we can
Move forward.
yeah, we can move forward.
Okay. All right. So just like what we did for Azure, we also need to do the same for GCS. I don't know who's on the call right here today. I'm just going through the list here. But someone will have to go do the same thing for
so
GCS.
just one note. Sorry,
Mm-hmm.
I'm just checking. Actually, you cannot revoke the SAS token.
Can you delete a token?
No.
So what happens if you have a workload that you've given access to, and the workload becomes infiltrated or goes rogue or gets hacked? How do you cut it off?
Mm-hmm.
You have to change the account keys, basically the secret keys, the 2 secret keys.
So you're telling me that even if you have multiple accessors, let's say I have 10 applications talking to one storage account, they would all have to use the root keys?
Yeah. I mean, you can mint a specific SAS token for them, but if you want to revoke the keys, you have to change the account keys, apparently.
So if I change the account keys, then wouldn't I have to revoke all the SAS tokens?
Yeah, the side effect.
Yeah,
would be,
it feels like this model is not compatible with what we've designed with Cozy at a pretty
Well,
fundamental level.
well, hold on. I don't think that model is usable just as it is. I don't think I'm pretty sure Azure has a better mechanism. I think we just don't know what it is.
Well, did they support S3 access, right?
So that they do have some S3 gateways, as far as I know.
Yeah.
But it's not native.
Right. I mean, I could understand why if you're Microsoft, you want people to use the native way instead of the S3 way. But if you use the S3 way, then you have a solution to this problem, which is every application gets its own access key and secret. And if any individual application goes rogue, you just yank that one access key, and you're in a good situation. So the question is, given that they can do that through their S3 gateway, what is the equivalent thing you do in the native way? Where if you want the existing applications to continue to run fine and you just want to yank one bad application and say, no, I don't trust you anymore. So there's got to be something.
So what they advise apparently.
Okay. So what they say is there's something called a shared access policy, and you'll have to create a shared access policy
Okay.
for BAR. You can revoke the whole shared access policy, but you can't revoke a single shared access or shared access signature that you've created for the same policy. You have to revoke the
Can
whole.
you have multiple policies?
Yeah.
Like 10 or more?
Yeah. That's what it
Okay,
looks
so
like.
So we
maybe
would- yeah.
maybe a BAR maps to a whole policy.
Yeah.
Yeah. And can you show how to create a shared access policy?
I'm looking.
Yeah.
Define a shared access policy. There it is. No permission list. Okay. This
Okay,
is just
that's
like IAM. This is no different from IAM. This looks exactly like it, except with an expiry, and yeah, you can do revoke and modify.
Okay. Yeah,
Yeah.
so as long as you can create one of these for every BAR or every BA, and then generate the associated secret or whatever for policy, I think that's the model you'd want to use here.
Right. Yeah, it is hard for me to imagine that Azure doesn't have a mechanism to create service account tokens on the fly and be able to revoke it. So had to be there.
Yeah. So the key takeaway is you cannot revoke a key, but you can attach the key to a policy and revoke the policy.
Yep.
Yeah. Okay.
Okay.
That's what we do.
So then we only ever give out keys that are attached to policies that we can revoke.
Yeah. Okay. That makes sense.
Perfect.
So if we go back to the definition, so we need it's not really a secret key, right? It's SAS token. But
okay, so we have endpoint, we have storage account name, we have container name. What else do I need? Secret key?
it's not secret key. It's a SAS token. I mean, unless we want to call that a secret key, but
okay.
And we can comment and say bound to so long-lived SAS token bound to a revocable shared policy. If you want to be, you know.
But I mean, these secret keys or SAS tokens, whatever they are, they're just bags of bits, right? It's just a byte array.
Yeah, well, it's actually it's a query param.
It's a what?
It's a query param. It's an HTTP query param. So you have the signature, which is a bag of byte, indeed. But you also have in clear all the components, like you have the expiration time. You have, I assume that if we bind the key to a policy, a shared policy, there is a shared policy name, for instance. And it's part of the SAS token. So it's a big string. So I'm not sure if you have to, if it works if you don't provide all the query params and you only provide the signature, for instance. Because what I've seen is only providing the whole set of strings, separated by ampersand. But typically you have, so the SAS token is a question mark because you're supposed to append this to the query. And you have, for instance, signature equal bag of byte, ampersand, expiration time, and you have, let's say, 10 years. And you have other parameters like that. So in practice, it's used like that. Now, if you remove all the extra stuff, right? I don't know if it works or not. I don't know. It's,
I see. All right, so I think now we have enough to move forward, right?
Yep, I think it's okay for me.
Ben, did you have a question about this?
No, just Just that yeah, just the things that are opaque should be opaque, and we shouldn't be too worried about what's inside of them.
So
Yeah.
you would, for instance, you would replace SAS token by token or key. Is it what
You
you're
want me
saying?
to rename this? Is that what you're saying? Are you saying that I should rename this?
I don't know. Is it what you want to do, Ben? Or
Oh, okay. So now that we have some consensus on what we want to do for Azure, can we move forward to talk about GCS?
okay.
Yeah. Okay. So I need someone to sign up to go look at GCS as well. Ideally, someone who's had even the tiniest bit of experience setting up some kind of cloud storage or yeah, they call it Google Cloud Storage in the Google Cloud. So who can I rely on for that? Who has tried this or who is interested in doing this? At the end of the day, I'm going to need someone here to go do this and get back to me on how we should design the API for GCS.
Maybe we can ask Andrew Lard to.
Yeah, I was
That
going to
would
say we had some participants from Google originally who would presumably be able to do this in a snap.
all right. Let's invite Andrew Large again. We've got his email. We can do that. Okay. So let's move forward. So here's one of the things that I wanted to discuss. So I've been updating the KEP, and one question or one thought that came while doing that was we have we've tried to define the concept of there's the bucket star type resources, and then there's the bucket access star type resources. What I mean by that is there's bucket access request, bucket access class, bucket access, and then bucket request, bucket, and bucket class. In this paradigm, the way we've defined the class part of this, the bucket class and the bucket access class, I believe we might have gotten some things wrong there. Because as it is today, we define this concept of, well, there are a lot of concepts in there that don't make sense. For instance, allowed namespaces. And also the current way we have where we define stuff like the protocol inside the class. I think we got a few things wrong while doing that. And I was thinking about how we did this or why we made the decision this way and what we can do to fix this problem. I'll tell you what the problem is first.
Well, hold on, you're making me nervous because like the allowed namespaces thing, I agree, is very hokey, but like when we started talking about how we were going to handle brownfield cases where like you were just going to point a BAR directly at a B, like it became evident if that's how we were going to do it, allowed namespaces was going to be the only security mechanism we had. And
No, I don't want to take it out. I just want to
okay,
improve
okay.
it. Yeah,
Can you look
yeah,
at the gateway API? I think gateway API have something similar.
yeah,
We
yeah.
are not now namespace.
So first I want to define what the boundary is for a class. I think we got that itself wrong. Currently we put protocol structure inside the class, and I don't think protocol structure should be inside a class because protocol is more specific to a particular bucket, or in a sense currently. Yeah.
Okay,
You're
so
saying?
I agree. You don't want a whole protocol structure, but like you do need a protocol enum. Like, is this going to give me an S3 bucket or is this going to give me a GCS bucket? Because if my workload only speaks Azure Blob and doesn't speak the other protocols, then if you give me an S3 bucket, it doesn't do me any good.
But if your workload only speaks, okay, let's talk about that. So can that still be encoded? So can we still have that information inside the bucket request rather than the bucket class? Because the workload requests using a bucket request, workload cannot create a bucket class, and they'll have to rely on the admin to do this for them.
Right, but what would it mean if the workload requested an Azure blob and like I didn't have a driver for Azure blobs? I only had an S3 driver.
So like, exactly what would happen if you did the same in CSI?
So Sid, historically, we had a subset of protocol. Later on, the
Right.
core team added those other fields. All we had was a protocol string. There was a
Right.
desire to share a common structure between the bucket instance and the bucket class. And that's why protocol has these fields that don't make sense from an admin point of view when creating a bucket class. But that was the reason. Secondly, we talked about drivers that could support more than one protocol. And we said, and Google was used as an example, and we said in that situation, they would create two bucket classes, one for protocol X and one for protocol Y. The third thing is we're trying to make the creation of a bucket as abstract as we can to the user. And so they're just saying, I want a bucket, and here's the bucket class I use. And they don't necessarily need to know the details, although it's a fair point that they're supposedly it's their workload that's going to be consuming the bucket. So there is a connection, maybe a stronger connection between workload, protocol, and bucket class than we have for a typical CSI. Although if my CSI workload is file-based and my bucket class is block-based, it's not going to work either. So that's kind of interesting, but I wanted to give you the history.
No, that's a really good point, and you said it very nicely. So if you look at what CSI does, the storage class concept in CSI does not have any information about whether it's a file or a block. The storage class inside the CSI is more or less used for Kubernetes level abstractions, like stuff like wait for first consumer or what the driver name itself is.
But Sid, that may be for historical reasons because storage classes predate the concept of volume modes. I think that if volume modes had been in from the beginning, they might have surfaced their way up into storage classes. I agree with everything Jeff said. The way I think about it is the idea of having storage classes or bucket classes is it's a way for the admin to sort of present a menu of options to the users that in some way reflects what is actually wired up on the back end. Because the idea is if you're just a consumer, you don't know on the particular Kubernetes cluster that you're attaching to exactly how it's been configured, what drivers are back there, what's underneath the infrastructure. So you just know that there's something, and the way you go look and see what your choices are is you enumerate the classes and you pick one, or if you really don't care, you let the default one get chosen. But if you know, if you can possibly care at all, you would enumerate over the storage classes, find the one that best matches what you want to do, and then use that for all your PVCs. Same thing with buckets, I think, is you know, if you have a couple different cozy drivers installed, you'd have a couple different bucket classes to represent them. But if you only have one, then you just have one, and it's the default, and everyone's going to get it.
Let's consider. Say good.
And I was going to say, and that's good, right? Even if the one you have is the Google one, like it still needs to be told, am I vending GCS buckets or am I vending S3 buckets?
Does that
You
need to
can
come
have
from the
both
bucket
options.
class, though?
Huh?
Does it need to come from the bucket class though?
Well, Kubernetes needs to know because maybe I have the GCS driver and it can support GCS natively, but I don't want to expose that to my users. I just want to give everyone S3 because I care about portability more than getting the most out of my object store.
But could you use labels to do that?
Labels?
I don't know. Can you label
some of the mechanism?
I mean, labels aren't meant to have semantic information in them. I think that, I mean, at some point, like we're going to send a bucket creation request to a driver, and it's going to have to say like, I want an S3 bucket, or I want a different protocol, and then you're going to have to populate different structs, and then you're going to have to fill in a different part of the bucket access object. And you're going to have to send different stuff down to the downward API. I mean, the protocol matters in all of these places, and so you really want to know from the top which protocol you're dealing with for a given bucket, and just having it in the storage class sort of gives you a starting point.
if it were not in the storage class, would we be severely disadvantaged? I feel like if we had just um, if the bucket class just represented common parameters that were not protocol specific, but that only applied to the Kubernetes wiring of this whole bucket lifecycle, that's what bucket class should encode. Having protocol specific.
The problem you're going to run into is like, if my workload only understands S3, and if someone somewhere creates a Kubernetes cloud with multiple bucket classes, and some of them can do S3 and some of them can't, if I somehow get the one that can't, then I'm going to get useless buckets. Like it's just a fact of object storage that the protocol can be non-negotiable, right? Like there are applications that can speak multiple, but if you only speak one, you only speak one, and
I mean, given that the list of protocols is finite, and we can clearly represent the protocol with a simple string, what if we just had a string field to represent what the protocol? That's
what I was arguing for. Is
okay.
It's an enum really, but you could represent it as a string. You know, it's S3 or it's GCS or it's Azure Blob. And I don't know
in
of
storage
any others.
classes. In storage classes, it's typically being encoded in the name, right? A lot of times you see the name, say AWS or whatever, right? EC2 or things like that, right? That's the current practice. I'm not saying it's good, but that's currently what happens.
Yeah, but with the storage class, like it really doesn't end up mattering, because any volume still gives you a volume, except for the whole file system block dichotomy. Like there is a problem there where, like, if some storage classes can do blocks and others can't, and I want a block's volume, like it just sucks, right? The design is not good with regard to storage classes and blocks, but that's because of history, right? It's not because of they designed it that way. It's just because storage classes predated block volumes, and we can't go back and cram block support into storage classes.
But you're saying that the workload doesn't care to anything other than the volume mode, right?
Right. The volume mode is the one thing that you might care about, that the storage class could help you work around. Everything else, you know, it's just going to work for volumes.
Well, there might be a lot of cases there, right? If you set up anything like NFS, you might have more things that don't work if you set it up incorrectly, right? For your workload. Like if you said, sorry, I meant like UIDs or whatever, like any misconfiguration of how that you know that file system basically provides your workload with access can be more complex than just the fact that it's a file system.
Yes,
permissions.
In particular, when you get into like multiple pods sharing access to a volume, you can end up in a world of hurt depending on, you know, what storage class you end up with. But like the basic case of one pod that needs a volume, it's going to work no matter what storage class you pick. If you have one pod and it wants a file system volume, you're pretty much guaranteed to be able to work with any storage class. So like that is the simple case. And then you're right, there are complex cases where you have different UIDs or multiple pods or block volumes, and then you can start to have trouble.
Like even affinities and you know, things like local volumes or whatever, right? There's more cases where it does matter to the workload how to configure itself based on what type of storage class it uses, right?
Yeah, but I guess the way you think about those are all additive things, like you know, extra features that you enable on your storage class or your volumes to say, like, I want this stuff. You know, if you leave everything blank and just say, give me the simplest possible volume and attach it to the simplest possible pod, like that's going to work 10 times out of 10.
Right. So I think volume mode is the one that's most similar to protocol, because it's like the top level selection, right?
If you want to block volume and someone gives you a file system volume, it's useless.
Doesn't work. Yeah.
And then similar here, if you want an S3 bucket and someone gives you a GCS bucket, again, you're dead in the water. So like, I see that as a useful top level thing, and it gives workloads a clue of, you know, which, or an easy way to filter through a list of storage classes, right? Or a list of bucket classes, I should say, list of bucket classes.
So you
Yeah,
would
maybe.
imagine that kept for storage classes, adding volume mode at some point, maybe.
I think he means that that's the right approach, but we've already moved on and kind of worked with the kind of made we've been able to work with the storage class without a volume mode.
I
How do we
mean,
do it today?
we
No, it's
could.
always possible to encode it in the name, right? You can always say this one is a block and this one is like just by name. It's always possible to encode it
Right,
somewhere else, but
Yeah, but we could write a kept to add like supported volume modes to storage classes, so that you could mark this storage class supports block volumes and file system volumes, or only block volumes, or only file system volumes. But the problem is always going to be that it would have to be optional for backwards compatibility, meaning that you're always going to have
Yeah.
situations where it's just going to be blank and you have to guess. So that's probably
Historically.
why there hasn't been pressure to add it, because even if we did add it, it would only address some small fraction of real world use cases, just for backwards compatibility reasons. Here we have an opportunity to get it right from the beginning. And that's why I'm arguing for, just a string, the protocol name, S3, GCS, Azure, blob, have it be,
Yeah.
have it be type checked so that you don't get garbage in there. So it's a proper enum type, but yeah, string.
Yeah.
and do you expect the bucket act this is, I see it's the bucket class and not the bucket access class as well, right? So put it aside for a second, but do you think also the request object should have a matching field to match that?
Yeah.
Like the
Yeah, that's what I was going to get to. So if we have only protocol name here, what should bucket request have?
Class name.
That's it. I mean, I would
Bucket
think
class name.
so. Protocol specific parameters. What do we want to request from about the protocol? Should it come from the class, or should it be something that the bucket request can?
What's a protocol specific parameter?
Region. Or anything else. Anything else from what we've defined here? Say endpoint.
So region's a tricky one because it gets treated as a top level thing by CSI, right? That CSI has a formal notion of topology, where things are, so that you can get your pods and your volumes in the same region, in the same zone. And that's all formalized in CSI outside of the PVC storage class thing. But what's another one other than region that you're thinking about?
So like something like bucket storage class. What that bucket storage class is like? What kind of redundancy does the bucket provide for the data stored in it? Stuff like that.
Yeah. I mean, you can do that with different bucket classes. You can have your bronze bucket class and your gold bucket class, and
okay. So again, just like storage class, you're saying.
Yeah, I mean, if that's how you want to slice and dice it, I mean, the nice thing about the storage class model is it's pretty flexible, right? It's just a menu, and how a given kube admin wants to structure his menu is up to him.
The question was if you want to match something, right? If you can slice anything, but like it's just names, right? The question is if it's so material to the workload that it cannot operate with anything else. The question is if I like provide a workload configuration like a YAML saying I don't care about the storage class, but I do care about the protocol. How do I specify that?
But the things you were talking about, like number of replicas or performance level, like those can't be material to the workload, right?
No, I just meant the protocol for a second. Just like in the specific field.
Yeah, the protocol needs to be a top level thing. I'm arguing that everything else can be opaque or handled out of band.
Okay, so just add protocol here. When I say protocol, I mean the protocol name, right?
Yeah, I'm not looking at the screen. Now I am.
Oh, just add protocol to bucket request.
Are you sharing?
I am. Can anyone see my screen?
Yeah. Okay. Bucket request.
We can see.
Spec has the bucket class name, and so from the bucket class name, you can
get the protocol name.
pull up the bucket class, and from the bucket class, you can get the protocol name.
So here's
Right,
the,
right.
okay.
But
So
how do
there's
you
one concern.
specify in a
Mhm.
workload what you expect to receive, right? If
Mhm.
that makes sense. I mean,
That
you
that
cannot
requires that would require looking at the different bucket classes and picking one that had the value you wanted. Right? There's
Okay,
no
so
magic.
what if there's no bucket class? Do you have, are we stuck with relying on the admin to give us a bucket class that that we can use to create a bucket?
Yeah, I'm pretty sure that in CSI land, if you have no storage classes, the dynamic provisioners will blow up. They'll say, I can't find a storage
It'll
class.
work. No, without a
Yeah.
storage class, it works.
What does it do?
You need the default,
Um,
right? Then you need the default storage class.
Mhm.
Dynamic provision.
Right. But if no, I mean, yeah, you can leave it blank in your PVC, but like if there is no storage class period, then like
No,
the
that surely won't work. But what
yeah,
about
okay.
volume mode? Like, let's go back to volume mode for a second,
Mhm.
right?
Yeah,
So
volume mode
if I
defaults to
provide a
file system.
workload, if I have a workload that expects a file system or a block, right, and I leave out the storage class, what am I? I'm in the PVC. I'm specifying at least that the volume mode I do have an expectation from
Yeah.
the infrastructure to provide me this or that, right?
Yeah, in that case, it'll find the default storage class and you'll get one of those if it supports the volume mode that you asked for. And if it doesn't,
Or not, right? It will fail, basically. It
right,
should.
but it won't go find another storage class that does support the volume mode you want. It'll just say, I
Fair
picked the
enough.
default storage class and it doesn't support what you want, and so you're out of luck.
It's fair enough that it fails, but at least it fails in the sense that it tells me, like, I couldn't find your request. I couldn't satisfy this request, and not I satisfied it, but gave me something incompatible to what I requested.
So what you're getting at is you would like the protocol to also appear in the bucket request so that you can be explicit about what it is that you're expecting.
Yep.
And then
I'm thinking for the workload, yeah. So that's what I'm saying, but I'm not sure that I'm like this is the right thing. I'm just asking, like, if I'm composing a workload configuration, what, like, shouldn't I be able to say I expect this or that protocol?
I guess the reason it makes me uncomfortable is because, like, if we didn't have it in the storage or in the bucket class, yeah, putting in the bucket request would be the right place to put it. If we put it in both, then you end up with this weird situation of, like, I can have
Matching.
a default
It's a
bucket
matching
class.
case, right?
Well, I mean, yeah, but I don't. I mean, the default storage class semantics are very, very simple in Kubernetes, and I was hoping that the default bucket class would be similarly simple. That, like, if you specify a bucket class, you get that bucket class. If you leave it blank, you get whatever single bucket class has been specified as the default, and there is no other behavior, like, because that's really easy to understand.
Yeah, but the names of the bucket classes can also represent different defaults, right? It can be gold, silver, bronze, right? Like we said, or whatever. So I'm saying that the default, in the sense of labeling, this is the default one or not the default one for a fallback one, I would say maybe, is one aspect of it. But there's just naming conventions in clusters saying this is the default for gold, this is the default for silver, bronze, and then these defaults, by saying I expect S3 or I expect GCS or I expect Azure, it just gives me a validation in terms of this is the workload that I created. I can actually hand it off to somebody, and it can be validated.
Names are for humans, so, like, what matters is what is the provisioner sidecar going to do when it gets a bucket with no bucket class, right? In the case
No,
of
I mean,
volume,
even if it gets one with a bucket class, I'm saying, like, if the bucket class is filled up with a name saying, I don't know, like default, cluster default, whatever, I don't know what the name will be that represents something like
and in that
fast.
case, then either the protocol in the bucket class matches the protocol in the bucket request and you're okay, or they don't and it's automatically an error. And so in this case, having the parameter in the bucket request bought you exactly nothing, right? Because if you specify the bucket class, either you specify the same bucket protocol and it works, or you don't and it doesn't work. And so, you're basically
So
forcing them to be
you're right.
identical.
You're right that it doesn't help you to recover. The only thing that it helps you with is to describe what doesn't work. Which in other cases, how do you describe to the workload that it got something unexpected? The workload doesn't even specify what it expected to work with.
Yeah, and again, we don't have a model to go from here, because in the volume world, basically.
No, the volume mode is one that the PVC specifies it, right?
Right, but I mean, from a historical perspective, like basically the way it works is everyone assumes the file system works everywhere, and if you request a block volume, good luck, right? That's what it comes down to, is the system does not help you find the storage class that supports block volumes. It's just, if you happen to know that it does and you ask for it, you'll get it. but if anything else happens, you're out of luck. And
so you're saying the volume mode is not in the storage class top level, it's like a parameter or some assumed value of the storage class, but there's still matching going on, right? There's like the provisioner will reject it,
right? But if the provisioner rejects it, that's it, you're done.
But that's fine, at least you got rejected. That you don't get a PV working and trying to run the workload and trying to understand what's like my workload seems to be.
Yeah, it's not a silent failure.
I see where you're going. Okay, so then the real question is, like, is there a way?
I understand why it's like on the other hand, I understand why it's inconvenient to have a double specification of a certain field like that. Like,
well,
it doesn't.
What you're arguing for is that it really does. Given that the workload, like if you have a PVC that needs a block volume, like you have to put that on your PVC, and like if the system can do anything other than give you a block volume, you don't care, because you either get a block volume or you don't. And so at that point, like you want that to be on your PVC. And you could argue the protocol is in the same boat. Like if I want an S3 bucket, then either the system can give me an S3 bucket or it can't. And if it can't, we're done. And I can get with that. But then the question is, like, how do you communicate that anything other than S3 will ever work? Because S3 is the obvious default.
At that point, do we need to communicate it? Events, or you go look at the volume object, you go look at the bucket object or bucket request object. It shows that it failed.
So what you would rather have happen is I create my bucket request, I put Azure Blob in the protocol, and then if I get installed on any Kubernetes cluster other than one with an Azure driver, it just fails to bind, and I go look at the error.
Isn't that how like pretty much everything else works? Like, think about load balancer services.
Yeah, but that's crappy. I mean, you're right, but that's again, it's an accident of history that we're in that boat. I think we can do better.
How so? Like the thing is, the user experience becomes scrappy if you have to rely on an admin to give you a bucket class with the parameters that you need, rather than being able to just use what you need. By saying, okay.
There's the question of control. Like what one nice aspect of storage classes is it gives admins a veto point, where there may be things that the system could support, but by not putting it on the menu, the admin prevents you from choosing that option.
Okay, so
something that would be nice as well is typically a vendor which supports, let's say, Amazon S3 and Azure. Could in their driver have the possibility of dynamically return credentials for the one which are asked, right? So for instance,
you're talking about dual protocol buckets where one bucket can support two protocols.
Yeah, because some vendors can totally support the two protocols.
Yeah,
right? That's our case, but
we haven't talked.
By the way, we're mixing here between access and the buckets. I started with that, but
my basic assumption from the beginning has been we would not allow multi-protocol buckets, even though I know some vendors could do it. Like it makes the API way harder to understand if you support it at all. And if we just take the stance that we're not doing that period, hopefully we can develop a simpler API. But we don't have to do that, right? We could say, no, we want multi-protocol buckets and we'll accept the additional complexity that brings.
So we only have 7 minutes left. I want to bring the focus back into the conversation on just bucket provisioning. The current way in which we provision buckets, we have to rely on admin to give us a bucket class with the parameters that we need, even though as the user, like I'm the one that knows what parameters I need for my bucket. Now, since the list of parameters is very small, as of right now, the only two things we can think of is protocol name and region. It might be okay. It's kind of possible to work with bucket class having the fields, but it seems wrong to me that the bucket class has anything to do with protocol at all. If we were to draw the line on the bucket class saying that bucket class is more to specify Kubernetes specific parameters, like just allowed namespaces and just stuff to do with how Kubernetes works with this, rather than.
But the protocol is Kubernetes specific because it's going to impact which fields of the bucket access get filled in and which flavor of the downward API gets shoved into the pod.
But isn't the workload that knows this really? Not the bucket
the workload cares. I'm saying Kubernetes has to know at multiple places in the workflow exactly what protocol it's dealing with.
Are you saying maybe a bucket class can be agnostic to that and just and decide, like the provisioner can decide on the fly, well, I do support this request or I do not, right? Just by saying, well, this request is for S3, I don't support S3, so I would just reject it. I would say I don't provide a PV for it, a bucket for it. But if I get requested for Azure, I say okay and I provide it, right? And like this comes back to the design of storage classes with the volume mode, where the storage class doesn't specify which volume modes it supports. It's kind of a, you discover it just by either knowing the names of the ones that support it or by trying it out and seeing what works or what doesn't, right?
But what we could do is, at the time you create a bucket class, we talk to the driver and ask the drivers if they support it, right?
No, there is no, like,
we
no
could
work
immediately
happens when you
reject.
create a class. Like, classes don't have like specs and statuses, and there aren't controllers that are processing classes in general. That would be a really unusual thing to do.
Yeah, but it makes sense.
No, but a request gets processed with it, right? The request itself gets processed with the class.
I mean, it's copied over to the bucket object and then indirectly, yes.
First, what's the point of creating a bucket class if the vendor doesn't support the type on the system?
No, I'm just saying the kind of policies that are in the bucket class should not have anything to do with protocol. In the sense, they should be agnostic to the protocol. You should be able to apply it across different protocols.
So we can do that if we move the protocol to the bucket request. And then you basically say with your bucket request which protocol you wanted, and given that the bucket class doesn't have any information, it's just whether the driver succeeds or not, right?
Yeah.
That is a workable mode.
We can still have that basic
like
level of
volume
filtering.
mode.
That would be like volume mode, where basically everyone kind of assumes S3 probably works everywhere, but then the other ones you just have to try them out. And in some cases, even S3 might not be supported. Like I don't know if there's a single CSI driver that doesn't support file system volumes and is blocks only, but there could be.
Yeah, there could be.
And
yeah, it's actually some driver, they separate them, right? They have one driver supports block, the other one supports file. Actually, many drivers do that, actually.
Could there be a driver that supports both?
Oh, yeah. CSI.
But actually, sometimes it's actually challenging. Sometimes we have some problems when supporting both.
Why?
Because sometimes we
the
want.
problems?
It's just there are certain things that we want to be. I think there are certain things that we can only tell for one type, but not the other. But if we support both, then there's no way for us to say that. So there are things like that.
Yeah, the way
think
the
it's,
CSI RPC is written, it gets tricky to deal with both because there's situations where you don't know exactly what you're dealing with until you do a little bit of work.
Then your
They
drivers
don't have the
also
class
support
in
both,
every
right?
request.
Yeah, we support both, and it's a pain in the butt.
Yeah.
No
Yeah, if
doubt
you look
about
at the
it.
GCP, their driver, they have two drivers. I think, yeah, I think like Azure, AWS, I believe they also have separate drivers. Yeah.
It might have been smarter to go down that when it
Yeah,
was originally done in CSI. Maybe we should have had a separate set of interfaces for block volumes rather than trying to cram them together. But we made the decision to cram them together and have it just be a parameter.
I see. Okay, so we're almost out of time. Actually, we're basically out of time. Let's continue this discussion on Monday, but I think we're going in the right direction.
Okay, but so tentatively what we're saying is maybe there will be no protocol information on the class at all, and it'll just come from the bucket request. We have to figure out what that means.
Yep.
And the access request also we need to consider, right? If the access also needs to have that.
Right.
Well, no, if it's on the bucket request, then you're done, right? If it says S3, then no matter what you do, you're getting S3.
Or you're not getting anything. Yeah.
Yeah. So if we put it on the bucket request, it's that's it. This concept of like multi-protocol buckets where maybe the access can be different on a per BAR, that's more complicated even than
I don't think that's what he meant. I think he's saying we should rework the fields in bucket access class just to make sure we don't have, we follow the same paradigm there also.
Yeah. Okay.
Yeah.
All right.
Yeah. And then once we're done with that, I think we have to revisit allowed namespaces, and then I think we should be good. It should be in good shape after that.
I'm not looking forward to revisiting that.
I have a pretty cool proposal. I think we have a good proposal. Krish has been working on it, so yeah, he'll bring it up Monday if we have time, and then we'll go from there. All right, thank you everyone.
Thank you.
Time's up. We'll talk again on Monday.
Thanks. Bye-bye.
Bye. Bye.